Hi, I'm Daryl Sandlin with Carolina Heat Pipe. I want to share with you this model we built to demonstrate how our heat pipes work. This model is based on an energy recovery application. We have two light coils, one placed in the exhaust or the warm air stream, the other placed in the supply or a cool air stream. The coils are then piped together and charged with a refrigerant. The coil in the exhaust picks up heat, the refrigerant boils, and the heat energy is transferred to the coil in the supply air. The refrigerant then gives up heat to the supply air, condenses, and returns to the exhaust coil. This is an adiabatic process that continues as long as there's a temperature difference between the two coils. The refrigerant flow is in one direction only. There are no pumps, no compressors required for the process. Energy transfer is totally passive. Here are the components. Two coils, the exhaust or evaporator coil and the supply or condenser coil. Supply air fan, exhaust air fan, and an electric heater to generate the warm exhaust air for this energy recovery simulation. Interconnect piping between the two coils. The top header is for vapor flow and it is warm to the touch. The lower header is for liquid return and it is cool to the touch. Here are the temperatures. The return air temperature is between the electric heater and the exhaust coil, and the exhaust air is after the exhaust coil. The difference between the two temperatures is the amount of heat energy picked up by the exhaust coil. In this case, approximately 15 degrees. This heat energy is then transferred along the vapor line to the condenser coil. The outside air is before the condenser coil. The supply air is after the condenser coil. The difference between the outside air and supply air is the amount of heat energy transferred by the condenser coil. In this case, about 15 degrees. The same energy transferred by the exhaust coil. Carolina Heat Pipe uses this heat pipe science to provide winter heat recovery between exhaust air streams and supply air streams, just as we've demonstrated here today. When the heat pipe coils are placed in line running around the cooling coil of an air handler, they will provide energy efficient dehumidification.